Hello, my name is Maria Suprun from the Icahn School of Medicine at Mount Sinai in New York City, and I would like to present our work recently published in the Allergy journal entitled Predicting Probability of Tolerating Discrete Amounts of Peanut Protein in Allergic Children Using Epitope-Specific IgE Antibody Profiling. Our group has previously published a study showing that a pair of IgEs to two epitopes can accurately predict peanut allergic subjects from non-allergic. And in this work, our goal was to determine if epitope-specific IgEs can predict the amounts of peanut protein that allergic subjects tolerated during the double-blind placebo-controlled food challenge. Oral food challenges are currently a gold standard for diagnostics, but those procedures are quite burdensome for both patients and clinicians. And a lot of effort is on the way to find a blood test that could serve as a surrogate or potentially replace oral food challenges. We have acquired plasma or serum sample from 406 peanut allergic subjects that were part of 5 different studies: BOPI, OPIA, Cafeteria, COFAR6, and PIPEDS, and those studies were also conducted across multiple countries. The age of participants ranged from 4 years to about 25, and all studies followed the practical guidelines for their double-blind placebo-controlled food challenges. However, still, as you could see from the schematic over here, the doses varied quite a bit, and some trials went as high as 4,000 milligrams for the total of cumulative tolerated dose of about 9,000, while others, like PIPEDS, stopped at 300. Then, to carry out descriptive analysis and machine learning, we randomly selected 75 subjects from BOPI and OPIA cohorts, and so this was our discovery cohort. After we have discovered and validated the machine learning algorithm, we would then tested it on the remainder of the subjects. In everybody, we have measured 64 IgEs against epitopes from 3 peanut allergens, Rh1, 2, and 3, using the bead-based epitope assay. First, in the 75 subjects that were part of the discovery cohort, we looked at the association between the cumulative tolerated dose and the amount or level of IgEs to epitopes. The heat map here shows individual patients as columns and their cumulative tolerated dose, and each row represents IgE against 64 linear epitopes from 3 peanut proteins. The color in red means more IgE, higher IgE levels. And what we can observe here is that subjects that were more severe here on the left, that tolerated less than 43 milligrams, have not only higher levels, but IgEs recognizing more epitopes in general, and this is opposed to subjects with a better outcome that could tolerate more than 443 milligrams, where we see less of those antibodies. Generally, the more IgE antibody subject had, the lower was their cumulative tolerated dose. Next, we wanted to see if we can identify a pair of IgEs that can predict cumulative tolerated dose of individual patients. Using machine learning, we have identified a linear regression with IgE to 2 epitopes, Rh2008 and Rh3100, that gave us the best prediction of cumulative tolerated dose. The performance of the model in discovery had a Spearman correlation coefficient of 0.61, which slightly dropped in validation to 0.51. We also found that it was quite hard to predict individual doses, mostly because the sample size was very limited. However, we did observe that as our predictor value increased, as shown in the scatter plot over here, there was a stepwise increase in the predicted dose. This helped us to further refine the algorithm by now splitting the patients into 3 groups at those natural sort of increase points that we observe in this plot. By doing this, we have assigned the patients into 3 groups: low-dose reactors, moderate-dose reactors, and high-dose reactors. And using the validation subjects, we have estimated the probability of tolerating different doses, amounts of peanut protein. And what we have shown is that more severe subjects, so those reacting at the low doses, for example, have about 53% probability of tolerating 44 milligrams of peanut, as opposed to high dose reactors where the probability is at 94%. On average, the difference between the low and the high group was fourfold. With this test, when a patient comes to clinic, they could be assigned into a reactivity level, which could help, for example, guide the further treatment decisions, as in patients in the low group could consider undergoing oral immunotherapy. To conclude, epitope-specific IgEs can predict probabilities of reaction to different amounts of peanut in allergic subjects and may provide a useful surrogate for peanut food challenges. The strength of the study is the separate validation and discovery cohorts, and we would really like to see next how this algorithm holds in the real-world setting. This work is now available in the August issue of the Allergy journal. Thank you.